Today we're going to be in Module 2, Lesson 3, solving multi-step equations. Most of these will be two-step equations and not three-step or four-step. But we've got a few more steps before, and when we did one-step equations like a plus 1 equals 7, we did the inverse operation. Or if we have x over 3 equals 7, pick 7 again, we would multiply because the opposite of division is multiplication. Okay? But now what we're going to be doing is doing two of these things in the same equation. So we are going to work with 2a minus 6 equals 4. And they did all of the work for us, but I don't want to do that. I want to actually go through it step by step. So if I look at this, the whole purpose of this is to get this a by itself. And what we want to do is we want to do the inverse operations. So what I'm going to say is, let's get rid of the subtraction first. So what's the opposite of subtraction? Addition. So I'm going to add 6 to both sides of the equal sign. Now, some of your teachers probably taught you to draw a line down so that if you go over that line, you have to do opposite operations. So I'm going to write 2a equals 10. Some of you are going to say, what happened here? Well, didn't that turn into a 0? So we no longer need that. Now, I still want to get rid of get my a by itself. Right now it has something multiplied by it, so I'm going to divide. When I divide, those cancel, and I get a equals 5. Now, to make sure that you have the right answer, you can do a checking step. So you can substitute back in for the a in the original equation, the 5, and make sure that both sides of the equal sign are the same, that this is a true statement. So look at that. It came out to be a true statement. So this right here is my answer. So the answer to 2a minus 6 equals 4 is going to be a equals 4. Okay, so now we're going to go right here. Oh, no, they just checked the answer. So now we're going to do this problem right here. And again, I want n plus 1 over negative 2 equals 15. Now, some of you are like, well, that just looks weird. Okay, so let's look at this. I can't really subtract anything to the other side right now. Why can't I subtract something to the other side? Because I've got this division going on. So I need to get rid of that division first. And we're actually going to be calling this clearing the fraction. When we've cleared the fraction on this, that means I want to get rid of the denominator. So right now there's only one denominator. So I'm going to multiply both sides of the equal sign by negative 2. And that will get rid of my fraction. These cancel out, so I'm equal to, it's n plus 1 equals negative 30. Now we're at a one-step equation, and we just do the opposite operation, which is subtracting 1 from both sides. So n equals negative 31. Now, I personally like to plug it back in and make sure that I did the right thing. Negative 31 plus 1 over negative 2. Does that equal 15? So that'll give me negative 30 over negative 2. Does that equal 15? It does equal 15. So that's a true statement. So n equals negative 31 is the answer. Okay. Now, down here. Okay, so now we're going to solve this one. So 3m, sorry about the phone. So I'm going to subtract 4 from both sides. I get 3m equals negative 15. I divide by 3 on both sides, and I get m equals negative 5. I'm going to plug that back in and make sure I did it correctly. 3 times negative 5 plus 4 equals negative 11. Negative 15 plus 4. Oops, negative 11. Negative 11 equals negative 11. So yes, we did it correctly. So this right here is the correct answer. Okay, so this next part, it says, student council raised 2/5 of the money they needed to cover the cost of the school dance with a bake sale. They raised an additional $150 selling raffle tickets. If the student council has raised $630, what is the cost of the dance? Okay, so the first things first is we want to know what the cost of the dance is. Okay, how many fundraisers were there? There were 2 okay, so they had a bake sale. I had to go back and read it real quick. They had a bake sale, and then they had raffle tickets. And then that came out to, they had a total of $630. Okay, so now let's look at this. Bake sale. Or what is it that we're looking for? Okay, what is it that we're looking for? It says right here, what is the cost of the dance? So let C equal the cost of the dance. Then what do we know? This says 2/3 of the money they needed to cut of. Didn't we say that's multiplication? So 2/3 of the cost of the school dance. C. And then that was from the bake sale, right? With the bake sale. Then they raised an additional $150 selling raffle tickets. Well, raffle tickets, maybe I'll change my color. No, I don't want that color. Raffle tickets, it says $150. And then it's a total of $630. So now that's the equation that we need to solve. Now, I'm going to actually solve it in 2 ways. First, I'm going to do this. I'm going to subtract the 150 from both sides. And then I'm going to get the 2/5 C equal, oh, I forget, the 0 didn't stay. There we go, or I didn't write it. So when I do that, I'm going to get 480 on that. Okay. Now, as we look at this, some of you are like, oh no, I don't like this. Now, I personally have no problem multiplying by the reciprocal. And so I'm going to multiply by the reciprocal because we don't divide fractions. We multiply by the reciprocal, like so. And I get C equals, let's see, 2 goes into this, 2, 4, 0. And then I multiply by 5, so that's 0, 0, 1,200. So it costs $1,200. Now there are some of you, when you look at that, you really don't like those fractions. So I'm going to show you another way to do it. Okay? If you really don't like those fractions, we can get rid of that fraction. Just like we did on one of the other problems, this has a denominator of 5. Oh, I'm going to use a different color. I'm going to get rid of that denominator. And I'm going to multiply both sides of the equal sign by 5. So when I do that, this 5 cancels with this 5. So I have left 2c. Oh, you're being silly. Okay, so I'm going to have to do this in my head. So, no, I'm going to do it out over here. 5, because that's 40, 20, so 2. Oh, I should have known that. Then I'm going to divide by 2 on both sides. And look at that. I still get that the cost, no matter if I do it clearing the fraction or I just multiply by the reciprocal, I still end up with $1,200. Okay, so let's go to the next one. Except for I don't want, oh, that's okay. We'll just do it this way. It says a sporting goods store sold two-thirds of its basketballs, but 8 were returned. Now, the store has 38 basketballs. How many were there originally? So, what are we looking for? Right here it says originally. And they used B, so we're going to do let B equal the original number of basketballs. Okay. Then this says 2/3 of its basketballs. So 2/3 basketballs, because you told me of means multiplication. Okay. Oh, wait a second. Let's go back. I have to read completely. Be careful. This doesn't say original basketballs. Look at this. This is not the original. This is not original. And we use B as original. So if they have 2/3 of the basketballs, how many more do they need? Or how many, how do I want to say this? So the original basketballs, there were 1/3 of the original basketballs. That's the missing part, because 2/3 plus 1/3 will get a full basketball. Oops, I should put B's. Okay. So what they have right this second is 2/3, but we want to know how many there were originally. So plus 8, because you're adding back the 8 that were returned, equals 38. Because this says now the store has. Okay? So it's what they have now. Okay? So then we need to solve it. So 90 basketballs. So this is my answer. Okay. Let's see if I can do this. Oh. Okay, so these are going to be a little bit different. Okay? These are going to be a little bit different. When you look at these, it says some equations have coefficients that are represented by a letter. So if I look at this coefficient has a letter. To solve these equations, apply the process of solving equations. So we're going to do the exact same thing. So my original equation is ax plus 7 equals 5. Then we're going to subtract 7 from both sides, just like we did before. We're going to subtract 7. When I subtract 7, I'm going to get negative 2. Okay, so some of you are freaked out right now, but it's wanting us to solve for x. So we're just going to get rid of what's in front of the x. Right now we have multiplication of a times x. So I'm going to divide by a, and I'm going to get x equals negative 2 over a. And that's your answer. That's it. That's it. Okay. I want to do the same thing. Actually, I just don't want... Okay, here we go. So I have 2 minus ax equals negative 8. Okay? So if I look at this, what's the opposite of 2? Subtracting 2. I'm left with, this comes straight down, so I get negative ax equals negative 10. Okay, I want x by itself, so I'm going to divide by a, or negative a, I apologize. So I get 10 over a. Okay. Now, what I would like to do is I want to go back to one of the problems that we had a minute ago. This one, the 2/5 c plus 150 equals 630. And I actually want to show you clearing the fraction when it's a whole thing. So I'm going to multiply everything here by 5, everything here by 5. When I do that, that's going to be 5 times 2/5 c plus 5 times 150 equals 5 times 630. When I do that, I'm going to get 2c plus 0, oh, that should be that, right? Yes. 0, 5, this. Then I'm going to subtract 750 from both sides. And I'm going to get 2c equals 0, 0. That's going to be 240. Or, sorry, not 240, 2,400 divided by 2. And c still equals 1,200. Okay, awesome.